This week in the news, we're going to talk about dinosaurs walking a really, really long way. The story begins in the Bighorn Basin in Wyoming. A team of researchers there years ago discovered pink quartzite crystals that were very rounded and identified them as gastroliths. Now, gastroliths are stones that are consumed or eaten by herbivores like cows, and then also dinosaurs that happen to be sauropods that are herbivores themselves. These rocks actually grind up in the stomach and help them digest, and in the process they get very rounded. Now, these unusual pink quartzite crystals were found in the late Jurassic Morrison Formation, at the height of the late Jurassic dinosaur period. But there's no pink quartzite in the Bighorn Basin. So where did these come from? A team of researchers based out of the University of Texas at Austin now have a story. These dinosaurs walked from Wisconsin all the way to Wyoming. The formation that contains a statistical identical rock to this pink quartzite, the closest one, is in Wisconsin. And the only possible theory is that these dinosaurs consumed these rocks in Wisconsin, walked 600 miles to the west, where they met their unfortunate demise in northwest Wyoming. It's an unfortunate story, but it goes to show you that a dino will walk a long way with the rocks on his belly. Geologists are used to looking at creatures of the deep ocean. In fact, we see in the rocks many historical examples of cephalopods. And one of those family members is the octopus. And recently in Western Australia on the beach, a geologist by the name of Lance Carlson came into a very unusual close encounter with an angry octopus. While he was swimming along the beach, the former lifeguard was attacked by an extremely angry octopus and was lashed with his tentacles, leaving marks and bruises. He lived to tell the tale, but for a geologist, this is kind of a nightmare come true. Long story short, for geologists and you're swimming in the ocean, looking at the rocks, don't turn your back on an angry octopus. Earthquake researchers don't just study quakes, but they study the quakes that come from the quakes. We call those aftershocks. In many parts of the world where there's tectonic motion along plate boundaries, we get earthquakes. Very large earthquakes can produce more movement, more stress, and that causes second aftershock earthquakes, some of which are almost as large as the initial earthquake. But in the Cascadia subduction zone, just off the northwest corner of the state of Washington, we have the Juan de Fuca plate, which is a tiny little plate that's being subducted beneath the North American plate, shoved in there by the Pacific Ocean. What's interesting is the lack of aftershocks that occur on earthquakes that form inside this plate. Most other parts of the world, Mexico, Alaska, have these aftershocks, but the Juan de Fuca does not. We're not 100% sure why, but scientists now believe that aftershocks are actually concentrated along the edges of these plates, where they're being stressed by the motion. They're colliding with the next plate, and then inside it's just a hot young plate, and it can take a beating, so to speak.